We've just discovered one of the most sophisticated supply chain attacks we've ever analyzed, and it's still active. This is the world's first self-propagating worm targeting VS Code extensions, and it's spreading on the two biggest VS Code marketplaces in the world using invisible code. So far, it's infected over 35,000 developers in just 2 days, through 14 compromised packages, and it's about to get way worse. In this video, we'll go through what it is, why no developer can see it or take it down, and how we found it and even managed to get into the hacker's server. And lastly, what to do if you've been infected. Here's how it started. Our risk engine at Koi flagged a VS Code extension called CodeJoy. A new version was pushed, and our system found some suspicious network connection and credential access. But when we opened the source code to investigate, everything looked completely legitimate. CodeJoy had hundreds of downloads, regular updates, seemingly normal code. But our engine kept warning us something was wrong. So we looked closer, and that's when we saw it, or rather, didn't see it. See these few characters we highlighted in the code? Look at how much the IDE counts. 6,500. This regular line of code, it is the malware. Let me say that again. The malware is invisible. Not obfuscated, not hidden in a minified file, it's actually invisible to the human eye. The attacker used Unicode variation selector, special characters that don't show up visually. To a developer, this doesn't look like anything. But to JavaScript, it's executable code. And if you think invisible code is sophisticated, wait until you see what it does. Before we go further, if you have an extension, package, or repo that you want to make sure it's safe before you download it, you can look it up for free at dex.koi.security and get full security breakdown. It's like Aristotle for non-binary software. It's updated in real time and is powered by our risk engine that took a lot of very talented people to build. So back to the code. We decoded those invisible characters to see what's actually written there. And what we found made our jaws drop. The malware connects to the Solana blockchain, a public blockchain, as its command and control infrastructure. And it's genius. Here's how it works. First, the malware searches the blockchain for transactions from a hard-coded wallet. Then, when it finds that transaction, it reads the memo field. This is a field where you can attach whatever text you want to the blockchain transaction. And that memo field contains a base64 encoded link to download the next stage of the attack. Here is why using the blockchain to access the payload is so brilliant and terrifying. The payload can't be tampered with. Once a transaction is on the blockchain, it can't be modified or deleted, and there is no one to contact or any way to shut it off. It's virtually impossible to trace back to a person. Security tools won't flag it because traffic to Solana nodes look completely normal. The attacker can easily change the payload and rotate his entire infrastructure for less than a penny by posting a new transaction on Solana. You're playing a game of cat and mouse, but the mouse can clone itself. Good luck. So there is this whole elaborate infrastructure, but what does the payload practically do? We downloaded and decrypted it to find out. There was a whole complex mechanism around dynamic keys in the HTTP response to make it harder to trace, but in short, we opened it and found out what GlassWorm really does. And let me tell you, it does a lot. The first thing the malware does is hunt for credentials of 49 different crypto wallets, MetaMask, Phantom, Coinbase, etc., with the aim of course, draining those wallets. But it also hunts for NPN tokens, GitHub tokens, OpenVSX credentials, and Git credentials. Why? This is where things get pretty insane, but to understand what it does with those credentials, we needed to take a look at the rest of the payload. Remember the credentials. So we kept digging and found something peculiar, a Google Calendar link. At first, we didn't understand this, so we dug into it and saw that the event title is yet another base64 encoded URL pointing at another encrypted payload. And this one is even worse. And before I tell you about the second payload, think about how smart it is. The attacker is using Google Calendar as a second C2. No one is going to block Google Calendar, so it completely bypasses security controls. It can be updated anytime by editing the event. And it's also unkillable infrastructure. It's a triple-layer C2 system. Solana blockchain, direct IP connection to C2 server, Google Calendar. virtually impossible to take down. And now, back to the scariest part of this attack, the zombie payload. It's a full remote access Trojan that turns your machine into a SOC's proxy server. The same machine that's behind all your firewalls and security tools and can access your internal systems. Attackers can route their traffic through your IP, accessing internal systems that external attackers can't reach. The malware downloads WebRTC for peer-to-peer communication with the C2, bypassing firewalls through NAT traversal. But it doesn't stop there. It uses BitTorrent's DHT network to distribute commands, the same system that makes torrents impossible to shut down. And the cherry on top? HVNC, Hidden Virtual Network Computing. Complete remote desktop access that doesn't show up in Task Manager, doesn't show up on your screen, operates completely invisibly. Therefore, the attacker can use your browser, access your email, read your code, pivot to other systems, do literally anything that you can do, and you'll never see it. Plus, it has automatic restart on any failure, so it won't go away. Yeah, you'd think that draining all your crypto wallets and giving an attacker full control over your entire machine is bad, and it is, but it's about to get worse. Remember those NPM tokens and GitHub credentials it's stealing? Those aren't just data theft. Those credentials are the key to how the malware can infect so many developers without them even knowing. Here's the full mechanism GlassWorm uses to spread. A developer downloads a legitimate-looking VS Code extension with invisible malware. The malware harvests credentials from NPM, GitHub, OpenVSX, Git. It then uses those stolen credentials to poison more packages and extensions with its invisible malware, and automatically push them to other developers. Each newly infected machine becomes a new infection vector, and the cycle repeats itself on its own. It's automatic. The victims don't need to do anything to get infected. The growth is exponential. It's a worm built to spread through the developer ecosystem like wildfire. Before we get into the impact, this is exactly the danger of supply chain attacks through marketplaces. We download small bits of code that we have no control over. Updates are pushed automatically, and traditional security tools don't detect them. If you want to make sure this never happens to you, get Koi. Koi provides one control plane to see, score and govern every extension, package and plugin your teams pull from external marketplaces. This includes the VS Code Marketplace, the Chrome Web Store, Hugging Face, Homebrew, GitHub and many more. Bad versions are blocked before install, risky updates auto-removed, and supply chain risk drops without slowing developers. Book a demo at koi.ai. So what's the impact of GlassWorm? This went down 3 days ago at the time of recording this. So far, 14 extensions have been compromised, 12 of which are actively distributing the malware. Over 35,000 have been infected and are now having their credentials stolen, wallets drained, and have been completely hijacked by an anonymous hacker. The C2 infrastructure is fully operational. The C2 server, Solana blockchain, Google Calendar event, they're all still up. There is even an active exfiltration server that's collecting all the stolen data. This isn't a case study. This is happening right now as you watch this video. If you want the quickest updates on the situation, follow Koi on LinkedIn. And here is an interesting twist. During the investigation, our research team managed to connect to an open port that was probably left open mistakenly on the attacker's infrastructure. When we connected to this port, we found that we can access secrets that have been stolen from the attacker's victims. So we found stolen cookies, stolen credentials, host names, IP addresses, and so on and so on. And right now we are trying to contact the relevant victims so we can let them know they've been hacked. What to do if you've been infected? If you're infected, our advice would be to reinstall the operating system. This is a complex malware and removing it is difficult. And of course, we'll continue to keep you updated through our LinkedIn and website. I'm Idan Dardikman, CTO of Koi. Good luck and stay safe out there.